So another example of exponential growth and decay is talking about compounding interest, right? And so you've probably heard of this when we talk about money, and we talk about compound interest when we talk about some sort of a value. And that happens all the time, right? And so on here, we see an iteration. It continues on and on and on, and we see what happens, some commonality. So if you were to take some amount of money and you add the interest from the year before, and you take that, you compound it, and it continues to go up, we end up getting through some examples, we end up getting this pattern that follows. So meaning that if we want to know the amount of money, it's based on a rate of increase, some percentage, also using time, right? So there's a couple different formulas, but what we end up doing is we end up finding this one right here. And this is important to know. Our compound interest formula is this. So we need to know a couple different things. A is our amount that ends up being in our account at the end of some amount of time. P is known as the principal, and it's the amount that we originally begin with, right? R is our rate, okay? Our rate, which is going to be some percentage written as a decimal. N is, notice it shows up actually twice. N is the number of times something is compounded in a year. So if it's, for example, if we talk about monthly, there was 12 months in a year, right? So N would be 12. Or if we talk about quarterly, you think of a quarter like a dollar. There's 4 quarters in a dollar, so quarterly there'd be 4 of them. And we'll look at a bunch of different examples in a little bit. Finally, the last one is time, T. Time, and it's time in years. So if they say over 6 months, that's a half a year, not a full year, right? Okay, so let's look at an example. All right, so it says Christy invests $300 in an account with 6% interest rate, making no other deposits or withdrawals. What will be her account balance after 20 years if the interest is compounded semi-annually, monthly, and then we're also going to look at daily, okay? So let's look at these. So we have kind of, we can find some of our information. So first off, our principal, she invests is $300. So P is 300, right? Then we need to know what R is. So R is 6%, so written as a decimal, 6 over 100, or moving the decimal place 2 spots to the left is 0.06. Okay, so that's our rate. N is going to change. So we're going to make a note of that. N equals question mark. And finally, the last one is our time. T is 20 years, right? So we're going to do this problem 3 different times, but we're going to change N every time and to see how much money is in our account at that time, right? So semi-annually, A is going to be, so semi-annually, semi means twice, annually in a year. So semi-annually would be twice a year, right? So we would have 300 times 1 plus our rate, 0.06, over 2 times in a year, to the power of 2 times 20, okay? So we can put this right into our calculator, and so we're going to do that. 300 times 1 plus 0.06 divided by 2 to the power of 2 times 20. And when we do that, I end up getting 978.61. And if you're unsure of how I got that number, you can check here. Make sure that you do this part in parentheses. That's very important. And also I would do this part in parentheses on your calculator, so you make sure that you get the correct answer. Okay? So if this was to be compounded twice in a year, which is, not normal for one of these, most of the time it's quarterly. But if you think of it semi-annually, there'd be $978 after 20 years. Okay, so it went from 300 to 978. Pretty good, right? But now let's say that it's compounded monthly, right? And this, you get a monthly statement. This kind of makes sense, right? So the only difference in this one is now our N is going to be 12. So we get A is equal to 300 times 1 plus 0.06 over 12 to the power of 12 times 20, right? And so again, I just go to my calculator and I figure this out. 300 to the power of 12 to the power of 12 times 20. And when I do this, this time I get 993.06. So notice it being compounded 12 times a year versus 2 times a year, I have an increase of about $15, right? $15 more. So about $1 more, okay, $1 more per compounding. Interesting, right? But now let's look at daily. And so obviously we know daily is 365 times in a year. And again, this would be really cool if you got this daily, but probably not going to happen. But let's look at it, right? So we get our A is equal to 300 times 1 plus 0.06 over 365 times 365 times 20. Okay? What am I calculating? When I do it this way, now you're probably thinking it's going to be a big jump, right? Big jump. So we do this, and we end up getting 995.94. So the difference of compounding once a month versus every single day is only a difference of less than $3 in the end in 20 years. That's interesting, right? So it goes from twice a year to 12 times a year, goes up by about $15. But going from 12 times a year to 365 times in a year, we still only get a difference of $2 or $3. Kind of crazy, right? All right, so what I'd like you to do is I'd like you to try this problem, and I'd like you to figure out. Actually, we're just gonna look at quarterly. Okay, so I want you to figure out how much money is in the savings account that starts with $1,000 after 10 years at 8% if it's compounded quarterly.